So, you've just gotten yourself a fresh pair of Timbs. Nice. Now, there's only one thing on your mind. Not are they waterproof, not how to style them, no. When you stare down at your 6-inch beauties, the only question is, can I destroy the universe with these? And the answer is, watch the video to find out, you impatient little rascal. Okay, to start off, we need to know what Timberlands are made out of. Timberland boots are made of mainly nubuck leather. So you basically have the ghost of dead cow on your feet. Right, so what if we destroyed the universe with nanobots? If we program solar panel nanobots to constantly create Timberland boots out of matter, then we could turn the entire universe into Timberland boots. This is also known as grey goo, which is a hypothetical catastrophic scenario involving molecular nanotechnology in which out-of-control self-replicating machines consume all biomass on Earth while building more of themselves. A scenario that has been called ecophagy. That's probably not right, but oh well. Eating the environment, more literally eating the habitation. So all we have to do is turn our Timberland boots into nanobots. Or Timberland bots. Haha, what a shitty joke, please don't stop watching, I'm sorry. But we probably won't have them fully working till the 2050s. Nanobots can be produced using organic materials such as proteins and, oh my god that's a big word, polynucleotides. Or inorganic materials such as metals or diamond. So sadly, we might have to ditch our nubuck and make fake Tims. No! Okay, well, it's the only way. The nanobots could still look like Timberlands. Shape, colour, would all be the same. Actually, because we are doing this on such a large scale, our nanobots wouldn't have to be so nano. Nanobots are constantly self-replicating, so they would constantly use matter and repeat the process over and over, until the universe has lost all matter and is just Timberland nanobots. The problem is empty space, that might contain no matter. We don't really know that much about the universe as a whole. We're pretty sure it's constantly expanding, which would mean our Timberland bots would need to catch up to the expansion. Although, we can't be completely sure. What might happen is that this could cause the Big Rip. Okay, so in physical cosmology, the Big Rip is a hypothetical cosmological model concerning the ultimate fate of the universe, in which the matter of the universe, from stars and galaxies to atoms and subatomic particles, and even space-time itself, is progressively torn apart by the expansion of the universe. If we had nanobots expanding faster than the universe, then this could ultimately lead to the Big Rip. In other words, victory. Now I propose we devote planet Earth to manufacturing Timberland boot nanobots. It's easier to just put nanobots in Timberland boots than have them create them separately. In this time period, we would all have to wear Timberlands. Just Timberlands. Nanobots are constantly self-replicating by using any matter around them and creating more nanobots. Now, at the moment, they are being thought of for medical treatments. Not quite our route. We don't even need our nanobots to be nano. Our main purpose for them is self-replicating, as Timberland boots. With these pesky little nanobots, we could shoot them into space so they can recycle all matter into more nanobots. I know what you're thinking. What's the point of them being Timberland boots if it's just nanobots? Well, shut up! It looks cool. Imagine a bloody solar system being turned into Tims. Never mind Higgs vacuums or whatnot. Death by Timberlands. I mean, just think of the aliens looking at the colossal wave of Timberlands destroying their universe. Fantastic. Another way I've thought of is what if we use kinetic energy and thermal energy to destroy the universe with heat? If we slapped a massive Timberland boot into the universe at ridiculous speed, maybe we could destroy the universe with a big ass Timberland boot. What if we made a massive Timberland boot, then it hit into the universe at unimaginable speed? My point is that if something moves really fast, it can turn the kinetic energy into thermal energy. The easiest example is making fire with sticks by rubbing them together at high speed. So what about a massive Timberland boot that could burn the universe?
Right, let's do this. Okay, well, let's look at your massive Timberland idea. If you're confused by the sudden change in voice, check the description. If you're too lazy to check, let me summarise. Woo! Collaborative video! The observable universe is a radius of 46.508 billion light-years, so the Tim would have to somehow be bigger than that whilst also being able to retain its shape. Ignoring the laws of gravity for a second, it would take a ridiculous amount of matter to create the Omega Tim in the first place. A single size 9 Tim weighs 595.34 grams. That's 1 pound and 5 ounces. The observable universe is also made out of primarily empty space, so the materials used in the creation of the Omega Tim would have to be sourced from elsewhere, as would the actual energy needed to propel the boot of the universe. We as humans know that the observable universe is only 46.508 billion light-years from centre to rim. Us, of course, being the centre of everything. And that isn't nearly enough space, so what about the unobservable universe? Well, the rough estimate is that the unobservable universe is over 250 times larger than the observable universe, giving it an estimated diameter of 7 trillion light-years. Assuming that we are able to eventually create a cheat code to move faster than light, and trust me, plenty of research is being done into that already, then there's an almost unfathomably large amount of matter that's ours for the taking. The only downside is that destroying the observable universe isn't destroying the universe, which means that if you really want to destroy the universe properly, then you have to get the material from outside of the unobservable universe as well. This is multiversal territory, and it's very theoretical, so much so that there are debates over physics working the same way outside of our universe. Long story short, that's probably not the best route to go. Right, going way back for a second, let's not ignore the laws of gravity and collapse our theoretical Omega Tim into a black hole. How many Tims would you need? Short answer, a lot. Long answer? If I'm not wrong, around... I'm gonna butcher this. 33 nonillion, 409 octillion, 500 septillion pairs of Tims. That's 26 zeros. Black holes are a result of immense gravity. Most of the universe is a result of immense gravity. I mean, hell, the sun is essentially a giant hydrogen bomb that's exploding constantly. If sound travelled through space, the sun would deafen everyone on Earth, and it's 152 million kilometres away. The only thing that prevents the flames from engulfing the Earth is that the rate of explosion perfectly matches the rate of the gravity generated by all of the matter, and this stops the explosion by pushing it inwards from all directions. Further into the future though, as the elements in the sun fuse into heavier elements that burn hotter, the rate of expansion will be greater than the gravity, and, well, the Earth will get a lot crispier. The first step in creating a Tim-fueled black hole would be to pile so many Tims into one area that they are crushed by gravity and undergo nuclear fusion. After a massive amount of time, the carbon in the Tims would fuse into iron, and this would result in the collapse of the Tim star under its own gravity. One of two outcomes would follow. Either a neutron star would be created, or a black hole would be created. We already know the ludicrous amount of Tims needed to create a Tim star that's sufficiently large enough to collapse into a black hole. However, I don't think an overproduction of Tims would really be a problem in this scenario. The initial black hole wouldn't be strong enough to absorb the entire universe, so humanity should begin dedicating the progression of society to piling matter into it. Any matter expended in the journey to get more matter to feed the Tims would be inconsequential and actually lead to a faster end to the universe. While this matter wouldn't become useless as a direct result of the Tims, it would be doing so in service of the supermassive Tim black hole, so I think it still counts. The only issue is creating a faster than light drive, because we just don't have the technology right now. But assuming that we will one day have the ability to travel faster than light through some physics-based loophole, there is absolutely nothing to stop us from piling the universe's matter into the black hole and then performing a nosedive into said black hole. If the destruction of the universe is defined as the destruction of all matter, then this would be considered a win. However, there is also the empty vacuum left behind after the black hole dissipates. To be completely honest, there might not be a way to remove the empty bit from space, as it's probably impossible to remove nothing from nothing. So again, black hole idea for the win. So, is that the only way to destroy the universe? Well, no, not really. The nanobot idea could work. I like that idea. I think it has some credibility to it. If by some miracle faster-than-light technology comes along, then fast replicating mini blobs of matter is probably the best way to go. Yeah, it sounds a lot like life when you phrase it like that, and I honestly doubt that that's a coincidence. If we program small robots to continuously self-replicate whilst also using excess carbon and water to assemble TIMs, and combine that with faster-than-light travel that is also assembled by the nanobots and then fired off in all directions, then the universe could be timified in a horrific and unstoppable chain reaction that would occur much faster than it would take for humans to forge the Omega Tim black hole. If we coded the nanobots to create 2 lightspeed ships for every planet, then 1 Tim planet would become 2, 2 would become 4, 4 would become 8, then 16, 32, 64, 128, 256, 512, and so on. Whilst this method wouldn't be directly destroying the universe, it would definitely change up the rules, and the universe as it currently functions would be entirely replaced by a Tim factory. But what is a Tim without feet to fill them? Also, the light speed would require energy to fuel it, and if certain Tim solar systems ran out of usable energy, the chain reaction could come to a complete halt in some areas of the cosmos. If we ignore energy requirements, then it would succeed 100%, but you can't just ignore variables. This is science, damn it! And we want to make Tims! All jokes aside though, even being able to destroy a small part of the universe is still quite impressive. And who knows, maybe universal destruction via Tims is attainable through nanobots, although a black hole would probably get it done, but take quite a bit longer. I mean, it's not like we're trying to be energy efficient, we want to burn through everything, it only speeds up entropy. And I'd consider accelerating the universe's decline into disorder through Tim production in, however way you do it, a success. But hey, that's just me. Ultimately, we are but small beings, not ridiculously small but small nonetheless, and any temporary impact on the universe is a win in my book. And while you definitely have to start small with your destruction, the sky isn't even the limit anymore. Good night.
Okay, thanks. Right, so you might not be able to destroy the universe with Timberland boots, but you can definitely destroy an anthill.